Everyone, welcome, and let's prevent the solution given this nice exponential equation, which is x subtract 3 to power 4. This is equal to 5 to power 4. So what is the value of x? Now, solution, we have that x subtract 3 to power 4. This is basically equal to 5 to power 4. Okay? Now, we can express x subtract 3 to power 4 as x subtract 3 raised to power 2. Okay? Everything raised to power 2. Subtract, now we take 5 to power 4 on the left hand side, so subtract 5 to power 4. This is equal to 0. Okay, now as you can see, x subtract 3 squared subtract 5 to power 4, of which you can express 5 to power 4 as 5 to power 2 raised to power 2. Okay, so here we'll have x subtract 3 squared raised to power 2 subtract 5 to power 2 raised to power 2. This is equal to 0. Now, this is actually in the form of a squared subtract b squared, which you can express as a plus b, a minus b. Okay, so applying this property, we'll have a as x subtract 3 squared, and b, this is the same thing as 5 to power 2. Okay, now applying this property, this means that we have a plus b as x subtract 3 to power 2 plus 5 to power 2. Okay, and then we have a minus b as x subtract 3 squared subtract 5 to power 2. Okay, cross the bracket, this is equal to 0. Okay, so now we have two parts here. We have the first part, you can call this one case 1, and we have the second part, of which I can call this one case 2. Okay, so let's proceed. Focusing on case 1, we have that x subtract 3 squared. Actually, this is in the form of a minus b squared, which is the same thing as a squared subtract 2 multiplied by a multiplied by b plus b squared. Now, applying this algebraic identity, we'll have x squared subtract, now 2 times 3x, which is actually 6x, plus 9 plus 5 squared. This is equal to 0. Now, in this case, we'll have x to power 2 subtract 6x plus 9 plus, this is 9 plus 5 squared, this is 25, this is equal to 0. Now we'll have x to power 2 subtract 6x plus, now 9 plus 25, this is actually 34, which is equal to 0. Now this is a quadratic equation, right? This is a quadratic equation in the form of ax squared plus bx plus c, which is equal to 0, with a equal to 1, b equal to -6, and c equal to 34. Okay, now let's assess the nature of this quadratic equation by determining the discriminant value, which is basically b squared subtract 4ac, and therefore substituting the value of b, we'll have -6 squared subtract 4 times a, which is 1, times c, which is 34. So here we'll have 36, -6 squared 36, subtract 4 times 34, which is basically equal to 4 times 4, this is 16. Okay, carry 1, then 4 times 3 is 12 plus 1, 36, which is 136. So this is equal to -100, and this is less than 0. So that means that we have two complex roots. We have two complex roots, which we can solve by introducing the quadratic formula. That is x1, x2, negative b plus or minus the square root of b squared minus 4ac divided by 2a. Applying this formula, we'll have negative b, which is -6, plus or minus the square root of b squared minus 4ac which is essentially equal to negative 100, divided by 2 times 1. So here we'll have 6 plus or minus. Now we can express this as 100 times negative 1 divided by 2. And this is equal to 6 plus or minus the square root of, now the square root of 1, we have the square root of 100. And you find that this is the same thing as 6 plus or minus the square root of 100, this is 10. And the square root of negative 1, this is I. Divide everything by 2. And therefore, that means that we'll simplify here. We'll have 3 plus or minus 5i. Okay? So we have two complex roots here. We have two complex roots here. That is x1. x1 is equal to 3 plus 5i. And x2, this is equal to 3 subtract 5i. So these are the first two solutions for case 1. So let's proceed to case 2. Okay, let's proceed to case 2. Let's proceed to case 2, which is essentially, for case 2, we have x subtract 3 squared, subtract 5 to power 2, this is equal to 0. And actually, x subtract 3 squared, this is in the form of a minus b squared, which you can express as a squared minus 2ab plus b squared. So applying this algebraic property, we'll have x squared subtract 6x plus 9 subtract 5 squared, which is subtract 25. This is equal to 0. Now from here, we'll have x to power 2 subtract 6x. This is subtract 9 subtract 25. This is minus 16, which is equal to 0. Now this is a quadratic equation in the form of ax squared plus bx plus c. This is equal to 0. Now from what we have here, we can easily get the product which is negative 16, and the sum which is supposed to give us negative 6x. Okay, and these two factors are negative 8 and 2. Okay, so if you say negative 8 times 2, this is basically negative 16. Okay, now for the product, these two factors satisfies the condition, and for the sum, which is negative 6x, this can be obtained by saying negative 8x plus 2x. Okay, so let's substitute this. We'll have x squared subtract 8x plus 2x subtract 16. This is equal to 0. Now find that x is common here, so we factor out x, so that we'll have x subtract 8 plus, now we have 2x and 16. 2 is common, so we factor out 2. We'll have x minus 8. This is equal to 0. Now in this case, we'll have x plus 2, x minus 8. This is equal to 0. So here we have two possible values. We have x plus 2. This is equal to 0. And we have x subtract 8. This is equal to 0. So that means that x3, this is equal to negative 2. And in this case here, x4, this is equal to 8. Okay, so that means that our algebra problem, we have got 4 solutions. Fine. We have, in the first case, case 1, we have that x1 is equal to 3 plus 5i. We have x2 is equal to 3 subtract 5i. We have x3 equal to negative 2. x4 equal to 8. So we have 4 solutions. So thank you for watching. Kindly follow the steps and like this video. See you in the next video. Bye bye.